At the outermost confines of our solar system, where sunlight dwindles to a chilly whisper and the familiar celestial bodies dissipate into icy hush, the James Webb Space Telescope has discovered something that has stunned the scientific community and awed imaginations around the globe. The improbability of what it found is not only in its remoteness or obscurity, but in the way it potentially redraws rules considered absolute. Through the darkness veil outside Neptune, Webb has looked into an area long held to be unchanged, a cold realm of small, old, and silent bodies that remain from the solar system's birth. But what had uncovered this shattered that silence. With its near-infrared camera, NIRCam, Webb looked at the trans-Neptunian zone, a world inhabited by Kuiper Belt objects, KBOs, and other icy dwarfs. While observing a dark, aspherical object thought to be an ordinary KBO, the telescope picked up unusual energy levels. Initially recorded as an ordinary stone, the object started exhibiting spectral features that didn't belong to ice, rock, or any known substance. Rather, it released something remarkable, pulsating bursts of mid-infrared radiation at a constant period. This hinted at internal heat and a source of power, something that shouldn't be possible so far from the Sun, where the temperature falls to near absolute zero. Further examination indicated subsurface geology, possibly even cryovolcanism. More eerily, the spectrum implied the existence of complex organic chemistry reacting with unidentified elements. The implications were breathtaking. The detection of heat, motion, and chemical activity in an object previously thought to be inert for billions of years contradicts our models of thermodynamics and planetary science. In contrast to moons like Europa or Enceladus, which receive tidal heating from giant planets to keep them active, this body is out there by itself, too far from any planet to be subject to appreciable gravitational heating. That leaves its energy internal. It might be the product of a radioactive core that has managed to store heat somehow for billions of years, or it might be suggestive of a completely unfamiliar mechanism of energy production. Either would call into question our current understanding of how small bodies come to form in deep space. Webb's high-resolution sensors also captured faint surface details incompatible with a mere clump of ice and dust. Delicate ridges implied tectonic-like behavior, and sharply fresh-looking fissures hinted at recent material venting. These were not the marks of a bygone collision, but indicators of current processes, beating like a pulse in the emptiness. Further to the enigma, the object appeared to harbor a weak, but detectable magnetic field, suggesting a partially liquid, conductive core, something considered impossible for such a tiny, far-away body. The find has rippled throughout several fields. If this object is not unique, the outer solar system could be far more dynamic than previously imagined. Complex organic molecules, possible precursors to life, have been detected, hinting that the chemical building blocks of biology may be forming even in the coldest, darkest corners of our cosmic neighborhood. The notion that life requires warmth and sunlight may be outdated. Here, complexity appears to be arising in an area unaffected by either. The discovery itself was nearly a fluke. This device was included in a wider survey designed to refine KBO orbital information, not a directed search for deviations. Only by accident did the telescope's timing, inclination, and sensitivity align to capture its peculiar behavior. It leads to an intriguing question: how many more like it are working undetected beyond our present eye? The object's orbit is no less mystifying, extremely elliptical, at times skirting close to Neptune's zone but for most of its time wandering alone. Even more notably, Webb observed a minor, mysterious acceleration in its path, too subtle for most to detect but unmistakable in the telescope's high-resolution measurements. This has revived rumors of the theoretical Planet 9 or another giant, unseen force in the outer solar system. More astonishing, Webb identified a dense cloud of dust and energetic particles enveloping the object, much thicker than anticipated at these distances. This cloud shows signs of being reactive, maybe sculpted by electromagnetic forces from the object. It's not just floating around through space, it's actively creating its own surroundings. Given this discovery, the definition of planetary science may have to be rewritten. If true, this may be an entirely new category of celestial body, spanning the two types or necessitating a whole new category. Word spread quickly throughout the astronomical community, and theories proliferated. Other scientists even ventured to postulate that the body could be a relic from a much larger world that once was out there beyond Neptune, its core somehow intact while its outer crust was stripped off by a devastating collision or gravitational destabilization. Others posited exotic ices capable of supporting chemistry at astoundingly low temperatures, releasing bursts of energy to simulate volcanic activity. Some, braver voices even speculated on extraterrestrial origins, citing the regularity and precision of the infrared pulses. Although such theories are on the fringe, the very peculiarity of the data has allowed them to be taken seriously. NASA and ESA officials promptly met jointly to consider sending a probe. The mission would be a challenge. The object's distance, well over 50 astronomical units from the Sun, means that even the fastest spacecraft built today would take decades to arrive. Yet the potential scientific payoff is enormous. If the energy source is natural but previously unknown, it could revolutionize our understanding of planetary formation and heat retention. If the complex organics point towards prebiotic chemistry or even microbial ecosystems underneath the surface, it would compel us to rewrite the history of where life can occur. And if, by some near unimaginable fortune, the pulses are found to be man-made, the finding would surpass science itself, the most important event in the history of humanity. Webb's ongoing observation has shown that the pulses not only follow a time pattern, but also a changing wavelength that appears to carry a repeating code. This may be nothing more than a natural resonance of subsurface processes with surface chemistry. But the mathematical regularity of the sequence is eerily close to patterns in prime numbers, a characteristic long suggested by SETI scientists as a possible signature of deliberate signals. The possibility that something natural or unnatural could be transmitting from the outer fringes of the solar system is almost too enormous to grasp. As more data floods in, new enigmas appear. The cloud of dust surrounding the object appears to ebb and flow in thickness, coinciding with the pulses of radiation. This indicates that material is being ejected from time to time, maybe from vents or fissures, and then spreading out in the surrounding vacuum. The weak magnetic field appears to rise somewhat during these processes, suggesting sophisticated interactions between the interior of the object, its surface, and its external environment. No object in the Kuiper belt is known to act like this. Speculation about a link to Planet 9 has grown. Some orbital modelers propose that the mysterious acceleration in the object's motion might be caused by gravitational pulls from a large, yet-to-be-found planet very far from Pluto. If this is so, then this object might be an important piece in charting the outer layout of our solar system. Others respond that the acceleration might be the result of outgassing, trails of material escaping into space, generating a small but detectable thrust. The issue is that the amount of energy needed for continuous outgassing in so cold an environment is, again, unexplainable by current physics. Public attention has gone through the roof. Social media streams fill with artist depictions of the object, some showing it as a broken, glowing shard of ice, others conjuring up an alien probe wrapped in frost. Science communicators are caught between trepidation and enthusiasm, weighing the requirement for careful analysis against the fact that the world's interest has been piqued. The enigma has even permeated popular culture, giving rise to books, movies, and interminable internet arguments over whether we are seeing the first whispers of extraterrestrial contact. All the while, at the science facilities that operate Webb, the work goes on. Teams are sharpening their spectral scans, searching for chemical signals that would resemble known substances or hint at wholly new ones. Cryochemistry researchers are simulating the way exotic ices could store and discharge energy over geologic timespans. Radio astronomers are pitching in, pointing deep space arrays at the object to look for any related radio radiation. So far, nothing out of the ordinary has been seen in the radio spectrum, but with the distances involved, even a powerful transmitter could be too weak to be detected with present instrumentation. Some researchers have pointed out the broader implications of the find. If such an object can exist in our own solar system, similar bodies may be common in other star systems. Exoplanet studies have already revealed a staggering diversity of worlds, many of which defy expectations. Adding active, heat-generating minor bodies in deep space to that list could open entirely new avenues of research. It also leads one to wonder how material from such corpses could travel between systems, possibly with complex molecules, or even microbe life, across interstellar space. This has, in turn, stimulated renewed interest in panspermia, the theory that life can be transferred between worlds through natural cosmic dissemination. If the Kuiper Belt or even more distant Oort cloud contains chemically active bodies with a blanket of protective dust, they might be both incubators and delivery systems for seeds of life. When conditions are right, pieces that would be flung from their surfaces might drift for millions of years before impacting a planet elsewhere, seeding it with the chemistry of biology. So far, the object is still unnamed, officially only designated by its catalog number. But informally, scientists have started referring to it as Prometheus, after the character in Greek legend who stole fire for mankind. The title captures the feeling that this icy traveler is bringing an ember of something surprising into the depths of space. Whether that flash is geological, chemical, or something deeper is the question that will propel investigation for the next several years. Webb will keep watching Prometheus as long as it can, creating a record of its activity over time. Other ground-based and orbital telescopes will join in on the action. The competition to know not only what this body is, but what it signifies, is on. And even as the answers will come slowly, years, or even decades from now, one thing is certain already: the outer solar system isn't the cold, dead graveyard we thought it was. It's a frontier still seething with processes we can hardly begin to comprehend, full of secrets that push the boundaries of human understanding. In the dark silence outside Neptune, something is moving, breathing, and maybe even thinking. The James Webb Space Telescope has pulled back the curtain just far enough for us to catch a glimpse of it, and now the world waits to see what comes forth from the shadows.